But today I will talk about carbonaceous pollution. And carbonaceous pollution, I will use three proxies or three parts of carbonaceous pollution: polyaromatic hydrocarbons, PAHs, spheroidal carbonaceous particles, tiny particles produced by burning of fossil fuel in combustion engines, and black carbon with soot and shard material. And we reconstruct these from part sediment sequences. And the reason to study this is this carbonaceous pollution, both black carbon, the particulate matter, and the PAHs, are important both for the climate system and for human health. And this, I just put up one slide here to sort of illustrate this. Climate Linear Coalition, which is a UN organization, just showing some of the health and climate interactions here. And they are huge. And we have good monitoring programs today, monitoring both particulate emissions and black carbon emissions. But the monitoring programs are quite short and limited in time. They're also limited to some extent spatially. And using the paleo data, we can extend this backwards. And that's really what I'm doing. And what I will show here is I will show two sites, and I have BC, SCP, and PAH reconstructions here. And the first site is situated, marine core situated in the strait between Sweden and Denmark. And the other is the core which I'm started to work with the same methods, which is a barred lake, annually laminated lake sediments in southern Sweden. And the cores cover the last couple of 100 years. Back to 1850 in the case, around 1850 in the case of the marine core here, coastal marine core, and back to early 1500s, roughly, in the barred lake sediment core. And this is in the strait. It's one of the busiest shipping routes in this part of the world. Don't think it compares anything near what you experience here, but all the ships coming in and out of the Baltic are passing through here. It's also for Scandinavia being a built-up area with Copenhagen, Malmö, Landskrona, Helsingborg, Helsingør, which have been industrialized quite long, and for this region, part of the world is quite heavily industrialized. And the core, I did it that way. So the core sits here in the northern part of the strait, and the strait is really narrow, kilometers wide, and has a mean depth of about 20 meters or a little bit more. And this is a pretty unique core. It's unique because the current velocities through the strait is normally very high, up to 1.5 meters per second, which means that we have very little sediment accumulation, and most places we have sediment transport through the strait. But we have one little deep hole or deep basin just north of a small island here, where we actually find continuous sediment deposition. It has shown difficult for us to come back to the same spot and retrieve more cores now. So it is a very small and limited station. It's also the route for water going in and out of the Baltic. So surface water, low salinity surface water are flowing out of the Baltic, and deeper, more saline water from the North Atlantic is flowing into the Baltic. This does affect the site to some extent. And we've been out here, been coring from Skagerrak, a small research vessel that we have used for a number of these types of expeditions. And we use a surface sediment core, the Gemini core, taking 2 core barrels in one shot, and getting nice undisturbed sediment cores, which we can slice on the ship and directly put in a freezer or start processing on ship on board. I have a number of these cores, and that's me and my colleagues are out there sampling. And what I've measured then in these cores, first maybe I should say that they're dated, the cores are dated by lead 210 dates. And the graph here shows the main data here. So it's a time axis, 2020 the top, down to 1850 in the bottom. It's dated using lead 210, so we have quite good chronological control of these four most upper part here. And then it shows total carbon, TOC, black carbon, BC, concentrations, black carbon influx, mass per surface area and year, so micrograms per square centimeter and year. Your SCP, spherical, spheroidal carbonaceous particles, both in concentration and in burial flux, and the concentration of the sun PAHs. And then just for reference, I've included the CO2 emissions from Sweden as a proxy for Sweden's industrial development, which is really what drives this. The black carbon is part of a continuum of partly charged to more or less condensed carbonaceous particles. The method I've been using is extracting the soot part, the most condensed part of the black carbon. And it's produced both naturally, forest fires, and by, to a large extent, by burning of fossil fuels. The SCPs are exclusively produced by burning of fossil fuels. And I have an SEM image of one of these SCP particles here. It's round, it's almost completely carbon, and both the soot particle and the SCPs are condensed, usually aromatic compounds that form and clump together and form these small carbonaceous particles. And then the polyaromatic hydrocarbons. The polyaromatic hydrocarbons are coming from combustion of fossil fuels and from the fossil fuels themselves. And they have put up look on anthracene and tricine. Is that right? It's anthracene. And what we see here, we have very low concentrations in the lower bottom part, low concentrations of all of these pollutants. And around 1870, we start to get the first observations of SCPs coming from combustion of fossil fuels. We have a little bit of increase in black carbon concentrations later on. And going further up, we start getting the PAHs in here. And this marks the first, oops, wrong way, marks the start of really sort of an onset of industrialization in this area. That starts sometime in mid-19th century. It has started earlier, but to a smaller scale. Around mid-19th century in Sweden is when it really takes off. And we start to see the first evidence of this. Going further up in the curve, or further up in the data, you see the big shift where black SCPs really takes off and PAHs really takes off. This is part of it starting in 1950s and the great acceleration when most of our industries in Europe. So we built a lot of that and we had a lot of activity. And you can see that it also fits well with CO2 increases in Sweden. Then if you notice, there is in black carbon, it's a decrease and a decrease in TOC. This is because of, at the same time, we also have climatic changes that change the current situation throughout the strait. And we have an increased flow for the strait. And we know this because we have another study we looked at foraminifera and looked at the climate side and modeled the climate of the strait. This does affect the deposition of the particles, and there is some sort of some hydrological sorting of the particles. It seems like it affects the total black carbon more than it affects the black carbon, the SCPs or polyaromatic hydrocarbons. We still get those, even though, or deposition of those, even though they have high current flow through the strait. This is nothing new with this. This picture we get here, we see an increase in the 1800s. We see this increase. It's really neat. It's really nice, and we have a peak here in SCPs clearly linked to CO2 and industrialization, industrial evolution. What is new is in the topmost part. See up here, the PAHs doesn't go down. The SCPs doesn't go down. The black carbon is not coming down. And this is a bit surprising because from the 90s, we started to implement regulation on these pollutants, regulating PAHs, regulating particular emissions. And it looks like at least at this site, in this spot, we get an addition of material here. And let's go away again. And we have this recent increase here. The likely cause of this recent increase is, no, I dropped the figure, or is it just waiting for the figure? Oh no. Okay, I can work with the other figure. There's supposed to be a stratigraphic figure there. It somehow disappeared in transfer between different parts there. Anyway, what I'm using here, I'm doing source appointment of the PAHs. I'm using diagnostic PAHs to say something from where these particles are coming. And we have this increase in the top, and we have this part before that, and we have this part with low concentrations. The part with low concentrations is really difficult to do this source appointment because concentrations are low and you can get any sort of, or your ratio is going to be a little bit unstable there. Whereas in the top part, and particularly the topmost samples, stand out. And this graph shows fluorantine to pyrene, then anthracene to chrysene. And these are giving different ratios depending if this is coming from liquid fossil fuels, combusted fossil fuels, or biomass burning. And in the pyrogenic, you got petrogenic, liquid fossil fuels, mixed source, and biomass burning. So anything sitting up in this right-hand corner are from biomass burning. Whereas if it would sit down in this corner, it's from liquid fossil fuels. And we get most of the young samples, the darker colors here, 2007, 2013, and so on. So the young samples are moving up to that corner. So that increase we saw here, that increase in some PAHs, that is driven by high molecular weight PAHs, and they're driven by more biomass burning. This biomass burning, or the increased biomass burning, next time I'm going to do my slides as PDF because I'm missing a graph here as well. This figure shows the use of biomass for heat production in Sweden. And that's colored by green wedge here. That's biomass. And we have 2019 back to 1969. The dark band here, that's fossil fuels. And this graph shows the outphasing of fossil fuels for district heating in Sweden and the replacement of that, the biomass. And before 1980, you had hardly any biomass for district heating in Sweden. From the 1990s, it really starts to take off. And it's steady increase, and there's a decrease in the use of fossil fuels. So it looks like in our data that liquid fossil fuels have been replaced by biomass burning. And in Öresund strait at this particular site, at least, that has caused an increase in the particulate carbonaceous pollution loading from this biomass burning. And it really starts in the 2000s and seems to be continuing. So I'm not really the first one to have identified this. There has been one paper from Sweden earlier and in 2007 that also interpret the data in this way. They show the same way. They have black carbon flux highest in the 50s, from the 50s, and they have PAH fluxes, which are really high and then going down. They interpret the increase they see in the topmost here in the 2000s and make quite a big deal of it in the paper, that this is because of increased use of biomass. This paper was published in 2007. The core were taken some years earlier. So with our core, we can add a few years to this. And it seems like this trend has been ongoing and continues. And we evidently have more pollution from biomass burning in Sweden, which is not surprising given this evolution, but you start to see it in the sediment record. So, and to continue this, so I have another site where I want to test this further. So I have a verb sediment sequence, and here's my colleague Yevgeny, who we're helping out, Ukrainian PhD, or his finished PhD, but helping out doing the coring. We took a freeze corer where you use dry ice to freeze all sediments onto a wedge and can get up a completely undisturbed sediment sequence. And after cleaned, it looked like this, and it's annual laminations. So a very good time control. And this also turns out to be a very good archive for black carbon. I was a bit worried, but you wouldn't see the next graph either. It's here. So I measured, so this is work in progress. I haven't only measured the black carbon so far. This is the black carbon curve, and the concentration calculated as flux. Interestingly, we have very comparatively high concentrations, almost 1% black carbon. This is really high. I think this is because of sediment focusing in this lake, and also the lake has no inlet or outlet. So for some reason, we get good preservation of black carbon. I've never seen these high concentrations in every course I worked on. So it seems to be a very good archive for black carbon. Probably because it's nothing is basically no particles are leaving this system, and there's very little inflow of mineralic matter. So it's just very low or very high organic matter content. What is really interesting here, we see the same thing, high values in the 50s, the big industrial revolution. What is interesting is that this seems to start earlier in 1700. Seems like the black carbon starts to take off already in 1700s. And calculating it to fluxes. The increase here is an artifact of our chronology and density that has not been well characterized in the bottom yet. Well characterized in the top though. But what we see interestingly is we have the same black carbon increase in the top here, indicating similar, probably might have a similar effect. I'm testing this. I don't have the data yet, but I'm testing this by doing radiocarbon measurements of the black carbon fraction. Because if my hypothesis, if what we see in Öresund is correct, and we can see it here as well, when we come up in the 2000s, the samples there should be biomass that should be contemporary ages. There's the fossil fuels that have infinite radiocarbon ages. So I'm hoping to get good radiocarbon measurements, and I have about 10 samples spread across the top part here to test this. Then, of course, you can ask us, there are a lot of questions you can ask if how relevant is this increase? Is it a real increase in particles and so? And I think this is maybe not part of my work, but maybe something that needs to be thought more about, how this is related to ongoing global climate change and so on. The particles from biomass versus fossil fuels. So on my little conclusions, I see this. higher deposition of black carbon and particles and PAHs from biomass since year 2000 roughly. And I have the you can say normal pollution history in this. What is interesting in Odensjön, the small barred lake, I have a very early increase in black carbon. And the paper has just been accepted. So the paper on the Marine Corps has just been accepted. So if anybody wants to read this story, send me an email. I'll send you the manuscript. It will come out in a couple of weeks, I guess, in printed form. And there's a whole bunch of people who contributed in some way to this. So I don't need to mention too many. Helena Philipson is she's one of the professors and more colleagues I've collaborated a lot with. And then we have postdocs, PhD students, and students that have been helping out in various stages along the way. So thank you for your attention.